I am Bhaskar, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology. In today's class, we are going to see Fourier transforms. Fourier transforms. Right. Fourier transforms. Fourier transforms. Fourier transforms. We are going to see in today's class Fourier transforms. Right. So what are the formulas we will apply in this Fourier transforms? In this Fourier transforms, we will study Fourier transforms, Fourier cosine transforms, and Fourier sine transforms we will study. Only 6 formulas. If you know the 6 formulas, any kind of problem, we can simplify it very easily. Right. I will write the formulas. So formulas, that 6 formulas I am going to write now. Right. First one should be, I'll write here type. So what type we are doing, that is nothing but type here required. So after the type, next one should be transform, and next one should be inverse transform. Next one should be inverse transform. Inverse transform. Here I am going to write the formulas. Right. First one should be Fourier transform. First one is Fourier transform. Fourier transform. What is that Fourier transform here? See, first one, integration of minus infinity to plus infinity f of x into e power iux into dx. That only we will denote it as f of u. Inverse Fourier transform is 1 by 2 pi into integration of minus infinity to plus infinity f of u into e power minus iux into du. That only I am writing as small f of x. Clear? So this is Fourier transform formula. Next, Fourier cosine transform. Fourier cosine transform. Fourier cosine transform. But that Fourier cosine transform is integration of 0 to infinity f of x into cos ux into dx, that equal to f c of u. Fc denotes that cosine transform. Fc of u. Next, inverse. What is that inverse formula? Inverse formula is 2 by pi into integration of 0 to infinity fc of u into cos ux into du. This only I'll write as f of x. Here fc of u, where we found out? We found out fc of u here. That fc of u only we will use this. Right. Next, Fourier sine transform. Fourier sine transform is integration of 0 to infinity f of x into sin ux into dx. That is nothing but fs of u. That only I'll write 2 by pi into integration of 0 to infinity fs of u into sin ux into dx, sin ux into du sin ux into dx equal to f of x equal to f of, that only I am writing as f. Right. So this is Fourier sine transform formula I have written. Next, we'll simplify the problems using this. See, this is Fourier transform formula, Fourier's cosine and Fourier sine. They will specify which one you have to apply, either Fourier transform or Fourier cosine transform or Fourier sine transform. They will specify that only you should have to do that, use that formulas. When you will apply this inverse means, whenever they will tell, they will give, prove that some sin x by x equal to pi by 2 or something you have to prove. That time only we have to use inverse transform. If something they didn't give, prove that like that. So not required to use inverse. Only you have to use the transforms only. Right. First problem we'll write find the complex Fourier transform. First problem, find the complex Fourier transform. Find the complex Fourier transform. Complex Fourier transform of the function f of x equal to 1 for modulus of x less than or equal to a, 0 for modulus of x greater than a, hence evaluate integration of 0 to infinity sin x by x into dx. This is the question. Here see, find the complex Fourier transform of the function f of x equal to 1 for modulus of x less than or equal to a, 0 for modulus of x greater than a, hence evaluate 0 to infinity sin x by x into dx. Right. How do you simplify this? Means here they didn't tell that either Fourier cosine or sine like that, they did not specify. That's the way we have to use first Fourier transform. Then afterwards, here some deduction is there. That's the way we have to use inverse Fourier transform. Right. Solution. So we have to use first Fourier transform formula. What is that Fourier transform formula? Fourier transform formula is nothing but f of u equal to integration of minus infinity to plus infinity f of x into e power iux into dx. This is f of u. Here, what is f of x? Here they have given f of x should be 1 for modulus of x less than a. What is that meaning of modulus of x less than or equal to a means? I'll write minus a less than or equal to x less than or equal to plus a, I'll write. This is the meaning of modulus of a less than or equal to x means. But what is that modulus of x greater than a means? After, see, before a and after a, that places that function should be 0. Now, this f of u only, I'll write like this, minus infinity to minus a f of x into e power iux into dx plus minus a to plus a f of x into e power iux into dx plus a to infinity f of x into e power iux into dx. I'll write like this. See, why I am doing here, I'll show here. This is minus infinity, this is plus infinity. Here, what is that? This is minus a, this is plus a. In between, what is there? 0 is there. Now, if you'll split minus infinity to minus a, this function should be here, this one should be 0. Here, the value should be here, should be 0. then a to minus a to plus a, the value is 1. Then a to infinity is, the value should be 0. Now I can use this and I will simplify like that. So this is the given thing, minus infinity to plus infinity, then minus a to plus a here they specified, right? Now I can take I'll take this one. Say next sheet I am going to write f of u equal to, so first two terms should be 0 here. F of u equal to integration of minus a to plus a, minus a to plus a. Remaining places that should be 0. F of x should be what that? 1 into e power iux into dx. E power iux into dx. Now 1 into e power iux should be e power iux only. Now I will write f of u equal to minus a to plus a is there. So minus a into plus a. 1 into e power iux should be e power iux into dx. Now if I will integrate this, we will get e power iux divided by iu. This is that integration of e power iux is e power iux divided by iu. But that limit should be minus a to plus a. Now I will take this 1 by iu. This limit should be in terms of x equal to minus a to x equal to plus a. So now 1 by iu I will take out. So if I will take 1 by iu out, so we will get e power iua minus e power iua. E power iua minus of e power minus iua. Now I will write, so that equal to 1 by iu into e power iua minus e power of minus iua. That is nothing but e power x minus of e power x is nothing but sin x. We will write sin x. Here divided by 2 is that, means we will write here sin x. Here divided by 2 is not that. That's why I will write that one should be 2i into, see here, 2i into sin x I will write. See once again I will write here e power x minus e power minus x divided by 2i is nothing but what is that? Here sin x. This 2i if you will multiply that side, you will get 2i into sin x you will get. So here that one only I will write. This is the formulas we have been studied at the lower standards. E power I theta minus of e power minus I theta is nothing but, I will write this one 2i into sin au. 2i into sin au I will write. In next step, I will cancel it. This here one I is there, here one I is there. If you will cancel that I, so now you will get 2 sin au divided by u I will write. This is nothing but f of u. F of u is nothing but 2 sin au divided by u. Now, the problem not get over here only. So because here something they have given, prove that something they have given. So that's a way to prove that, how to use this inverse formula. Right. To prove what they are given, to prove integration of 0 to infinity sin x by x into dx, we use inverse transform formula. We use inverse transform formula. What is that inverse transform formula? We know that. So what is that inverse transform formula? 1 by 2 pi. 1 by 2 pi. So we know that 1 by 2 pi into integration of minus infinity to plus infinity f of u into e power minus iux into du, which is nothing but equal to f of x. I'll write f of x here first in the starting. I'll write f of x equal to 1 by 2 pi integration of minus infinity to plus infinity f of u into e power minus iux into du. Now I will write f of x equal to 1 by 2 pi into f of x equal to 1 by 2 pi into minus infinity to plus infinity is there. What is f of u? You can write here 1 by 2 pi minus infinity to plus infinity. What is f of u? Here I found out. What is that? 2 sine AU divided by u. 2 sine AU divided by u into e power minus iux into du. Now, I'll write this one only. F of x equal to, in next sheet, I'll take f of x equal to, if you take 2 outside, so 2 divided by 2 pi, integration of minus infinity to plus infinity, sine AU divided by u into e power minus iux into du. I'll write this is. Now if I'll cancel it this 2, you will get f of x equal to 1 by pi into, here say, minus infinity to plus infinity, sine AU divided by u into e power minus iux into du. Right, here we should observe one thing. So in previous what we have to prove, that is important. Here I want to prove sin x by x. That time here sin AU by u is there. So I don't want this a term. So if I don't want a term, what I have to fix that value, we should have to guess, and trial and error method we have to do. Right. So if you don't want a value means sin x by x only is there. Here what is there? Sin AU by u is there. So here u is there, there x is there. There is not an issue. Now that's the way we'll choose a equal to 1, and I don't want at the same time this e power minus iux term also. What is that e power minus iux means? Here this term will become as 1 because dx coefficient should be over the there is no e power iux term. So that's why I will choose, the same time I will choose here x equal to. So what is that? Here u if we keep 0, denominator 0 will come. So that's why we choose a equal to 0 and x equal to 0 in f of x. We give x equal to 0 in f of x. What is f of x here? See, f of x already we have seen, and choose a equal to 1 and x equal to 0 in f of x. Right, but x equal to 0 lies between minus a2 plus a. Why I am writing this one minus a2 plus a? See here, because already in the problem we know that here f of x should be lies between modulus of x less than or equal to a. What that modulus of x less than or equal to a means? Minus a less than or equal to x less than or equal to plus a. So this 0 lies between minus a to plus a. So the time if I will give in the f of x equal to 0, in f of x I will give x equal to 0. What is the value of f of x? We will give x equal to 0 also. See, put x equal to 0 in f of x, then you will get the value of f of x equal to 1. Why? Because left hand side should be what term is there? F of x term should be there. So in that place I am going to substitute f of x equal to, now I am going to substitute 1 equal to 1 by pi into integration of minus infinity to plus infinity sin AU. A is nothing but 1 sin u divided by u into e power minus iux. X equal to 0 means e power minus 0 into du. Now I'll write, so that equal to 1 by pi into integration of minus infinity to plus infinity sin u divided by u, e power 0 is 1 into du. Now this pi I will multiply, cross multiply this side, pi equal to integration of, say here, sin x by sin u divided by u is even function. How can I say that this is even function means? If we will replace x by minus x or u by minus u, sin of minus u is nothing but minus sin u divided by minus u. Minus minus get cancelled, then you will get sin u only. Even functions, odd functions, we know that. So when you will replace f of minus x equal to f of x, you will get means that is even function. F of minus x equal to f of x means even. Minus f of x means that is odd function. F of minus x equal to plus f of x means even function, minus f of x means odd function. If we'll replace u by minus u, sine of minus u is nothing but minus sine u divided by minus u. Minus minus get cancel means you will get sine u by u. Sine u by u is nothing but again f of u. So that's only, I'll replace x by minus x. If I'll get f of x only even. If I'll get minus f of x means odd I'll get. So now pi equal to integration of minus infinity to plus infinity. Now I'll write this one should be sine of minus u divided by minus u into du I'll write. Now whenever it is even function, I'll write pi equal to 2 times of 0 to infinity. So I'll write here that this is even already proved. So minus u, I'll cancel this. So whenever it is even function means, if you replace, you will get the same function means, you will write this one minus infinity to plus infinity. We will write it as 2 times of 0 to infinity sine u divided by u into du. We will write. Now this only I will write pi by 2 into integration of 0 to infinity sine u divided by u into du I will write. So this I'll write. So I'll replace u by x. Because I want in terms of x, the solution should be given in terms of x. This only, that is sine x divided by x. What is that integration should be? 0 to infinity sine x by x into dx equal to pi by 2. What I have done here, just I replaced u by x, which is the required solution for the given problem. Any doubts? Here see, f of minus x equal to f of x means even function. Minus f of x means odd function. How do you check even function, odd function? Whenever the limit should be minus to plus, whatever it may be, infinity to plus infinity or minus 1 to plus 1, you will replace x by minus x. If you will replace x by minus x, you will get the same function means even. If you will get negative of that function means that is odd. If you will not get anything like that, so then it is neither even nor odd function. I didn't specify that. So here only specified only even or odd. Right? Any doubts in this problem? You can ask. Right. Next question we will solve. Right. Second problem. Find the complex Fourier transform. Find the complex Fourier transform. Find the complex Fourier transform of the function of the function f of x equal to x, comma modulus of x less than or equal to a, 0 modulus of x greater than a, where a is positive constant, where a is positive constant. So this is the given problem. So how do you simplify this? We can see, right, solution. Here already I told that. So what does that say? I'll put the line here. This is minus infinity. This is plus infinity. Here also once again they are given modulus of x less than or equal to a means minus a, and this is plus a. Here 0 point is there. So here minus infinity to minus a should be 0. Minus a to plus infinity is the value of the function is x, and a to infinity is also 0. So previously I explained, we know that here this place it should be 0, and this place should be also it is 0. Now we take this and I'll simplify solution. Right, you can see here they didn't ask any proof, only they asked to find the complex Fourier transform. In the previous problem, they asked what that find the value of integration of 0 to infinity sin x by x, like that they asked. Here they didn't ask anything, so that's the way. That's the way we are not we are not going to use here inverse Fourier transform formula. Only Fourier transform formula we will use here. Right. Now I will write f of u equal to, what is that formula I am writing? F of u equal to integration of x equal to minus infinity to plus infinity f of x into e power iux into dx. What is f of x? We know that. So this only I will write. Already I told that I will split like this. X equal to minus infinity to minus a f of x into e power iux into dx plus x equal to minus a to plus a f of x into e power iux into dx plus a to infinity f of x into e power iux into dx. Now I will write this one should be, first term should be 0, second term should be x equal to minus a to plus a. F of x should be what that x into e power iux into dx plus second term should be 0. Now I will write this one only, x equal to minus a to plus a, x into e power iux into dx. This one, how do you integrate? Means already we know that I'm going to apply here integration by parts or Bernoulli's rule only. We will tell that. We will apply Bernoulli's rule. I'll write here, see Bernoulli's formula. Integration of u dv equal to uv minus u dash v1 plus u double dash v2 and so on. What is that u dash? Is differentiation. V is nothing but dv. If you will integrate, you will get v. V1 means all the v function we have done one time. Here dashes, see dashes denotes that, dash denotes derivatives. Dash denotes derivatives. 1, 2, 3 denotes, 1, 2, 3 denotes integration. 1, 2, 3 denotes integration. Now I will take this one only, x equal to minus a to plus a, x into e power x into dx is there. So now I will take x e power iux into dx is there. So I will take this as u and this complete term as dv. One should be u I will take and another one should be dv. Which function will take it as u means normally. If we will differentiate sometimes, it may become 0. Such a kind of functions only we will choose as here u. Otherwise, we will use Eilert rule. So we know that Eilert rule is what? According to that, first inverse function is there means that function I will choose it as u. Or logarithmic function is there means I will choose it as that one use u. And algebraic function is there means that one I will choose it as u. First, which comes first, that only we will choose. Generally, we here in these problems, in our problems, polynomial and some exponential or trigonometric will come. The polynomial functions always we will choose it as u. That means algebraic functions. Now, if I'll apply this, using this, I'll integrate this and I'll get in the form of, first one should be u, another one should be what that, e power iux into dx. So according to this formula, u into v, u is nothing but x. This, if you'll integrate this, you'll get, I'll write here, see, u equal to here x, dv equal to e power iux. dv is nothing but that e power iux into dx, e power iux into dx. Now, first I will do u dash. What is the differentiation of u dash? Differentiation du by dx is 1. What is v? v is e power iux divided by iu. What is v1? v1 is nothing but e power iux divided by iu whole square. This only I will write 1 by I. What is that 1 by I value should be minus I. This only I will write minus I into e power iux divided by u. And this one should be minus e power iux divided by u square. This is v1. u double dash, what is the differentiation of u dash is 1, u double dash should be 0 and not required to find that one. So in next step I'll write, see, f of u equal, these are all just I have done. So according to, for your understanding purpose, actually in examination directly you have to simplify this. Not required to write this all. For your understanding purpose, I have done this all. Right. F of u equal to, first, what is that? U is x. V is e power iux divided by iu minus differentiation of x is 1, e power iux divided by iu whole square. Next, if we will go further, it will become 0. So that only I am writing. So here what that limit should be x equal to minus a2 plus a. Now I'll write f of u equal to 1 divided by iu into x into e power iux. Limit should be minus a2 plus a. And next one should be this one, minus of minus e power iux divided by u square. Here limit should be, what is that? Limit should be minus a2 plus a. Separately I have done these two terms. Now, so I'll write f of u equal to 1 by iu. If you want 1 by iu, I'll write minus I divided by u, I'll write 1 by I into, first if you'll apply upper limit, a into e power iua minus lower limit if you will apply minus a into e power minus iua. This is upper limit and lower limit. Minus of minus should be plus 1 by u square into e power iua minus e power minus iua. Is it clear? Upper limit I applied e power iua, lower limit I applied e power minus iua. Now here I'll take from the first term f of u equal to minus I. So here if I take a outside, minus ia divided by u into e power iua plus e power minus iua plus 1 by u square into e power iua minus e power minus iua. Now I'll write, what does this one say? F of u equal to minus ia divided by u into e power I theta plus e power minus I theta. E power I theta plus e power minus I theta is nothing but what I can write here, see, e power iua divided by e power minus iua is there. So now this one only I'll write 2a e power I theta plus e power minus I theta. In the place of theta, what is that here? ua is there. So now I'll write this one only 2 cos ua I'll write. E power I theta plus e power minus I theta is nothing but 2 cos theta you will write. So that one only 2 cos ua plus 1 by u square into, this one should be, I'll write 2i sin ua I'll write. 2i into sin ua I'll write. Now, here what I'm going to do this one, see I'll write here if you want the formulas. So how I have written that one, e power I theta plus e power minus I theta divided by 2 is nothing but cos theta. At the same time, e power I theta minus e power minus I theta divided by 2i equal to sin theta. Now I'll write f of u equal to, by using this I can write here everywhere should be I is there. I'll take 2i outside. So 2i if you will take outside, and similarly I'll take here, say first term should be u square is there. So now this one should be positive. 2i I took outside, sin ua divided by u square minus I took outside a into cos ua
divided by u, divided by u, which is the required solution for the given equations. So these are all you should know that. So using these concepts only we'll simplify. E power I theta plus e power minus I theta divided by 2 is cos theta. E power I theta minus e power I theta divided by 2i is sin theta.